Advancement in the wireless technology is one of the key reasons why IoT systems has evolved to this level. IoT is all about smart interconnected things. Internet of Things means smart interconnected things. So networking, communication is one of the key thing in the IoT system. And when you are implementing something in a wide area, then wired communication can be a nightmare. So wireless communication is something which comes as a bliss over there. In this slide, we talk about different kind of wireless communications which are available. PAN is personal area network. WPAN is wireless personal area network. For example, you have your smartwatch and the smartwatch is connected to your mobile phone. So typically Bluetooth, Zigbee, Z-Wave. They are the three technologies which are used devices to connect to the nearby devices. Then we have LAN. Wi-Fi is the most common example which you may be seeing in your office, in your home. You have a Wi-Fi router and your different gadgets connects to the Wi-Fi router, and using Wi-Fi router they can connect to each other or to the cloud systems. Then we have something called wireless MAN. MAN stands for Metropolitan Area Network, which are implemented typically in cities, sub-cities. WiMAX and weightless, they are the two very important technologies which are used in metropolitan area network. And then wide area network, wireless wide area network. So one common example we all know is our cellular technology, using which you can communicate to the backend systems. But in case of IoT, there are specific networks which are implemented for specific purpose. One such thing is called NB-IoT. NB-IoT stands for narrow band IoT, and there is also something called LoRaWAN. LoRa stands for long range. It's also called low radius. Low radius, sometimes it's also called long range wireless network, that is again implemented specifically for IoT systems. So narrow band IoT and LoRa, these two, the key characteristic of these two is low powered wireless technology. They consume very, very less power as compared to GPRS and GSM systems. So there are different standards for each of them. So for wireless PAN, we have 802.15. For LAN, it is 802.11. MAN 802.16. 802.20 is for wireless BAN. Zigbee is a personal area network. It's a very low powered, low data rate, and in the close proximity, it can be used, and it's primarily used in smart homes or smart gadgets. In your home, there are 10 devices. So you can implement Zigbee to connect these 10 devices with each other or with the other systems. Similarly, Z-Wave is a wireless communication protocol used primarily in the residential and commercial building. WinMax is another protocol which is used for metropolitan area network, and this enables a very high speed internet access over short distances. Short distances means couple of kilometers. Weightless is another wireless technology which is used for low power wide area network, LPWAN. LPWAN is typically the terminology which is used in IoT systems, that stands for low powered wide area network. So these are specifically designed for Internet of Things. So some of this you might have heard. For example, Bluetooth, you may be already aware. LAN, you may be already aware. LTE, 3G, 4G, you may be already aware. But some of these technologies like Zigbee, Z-Wave, WiMAX, weightlessness, NB IoT, or LoRaWAN, these are specifically used for IoT. In general use, people may not be aware of this. If you're working on IoT projects, you will get to hear these kind of words very frequently. If you're working on an IoT project as an IoT engineer, you may not be a network expert. Networking is a subject in itself, and each of them is subject in itself. Right? You may not be networking expert. You may have to work with the expert for integration, and therefore you should have a certain level of knowledge. Right? Similarly, if you're working on a device integration, you may not be a hardware expert. That's a field in itself. But you may have to work with the expert to integrate the hardwares, integrate the sensors in your IoT solution. Right? So in order to do that, you may not be expert, but you need to have certain level of knowledge so that you can interact with those experts. You cannot be absolutely dumb if you're talking with those experts. Right? So having knowledge of all these area is important. Expertise may or may not be there. If you are expert, is wonderful, but it may not be always required because you always have to work with the experts in the respective areas. low powered wireless communication is one of the key things in the IoT. So as I mentioned, wireless communication has played a key role in evolution of IoT. IoT evolution is directly proportional to advancement in the wireless communication. And in case of IoT, one of the very important thing we need is low powered. Low powered. Why low powered? Because many times when you have IoT devices, they may not be having regular power. They may be running on batteries, specifically when you are implementing something in the remote areas. If you are implementing something on the highway systems in agricultural rural areas, if you are implementing something for smart agriculture, if you are implementing something for forest, right, you may not have regular power supply over there. So those devices may be running on battery, and therefore it is very important that the power consumption is optimized. Otherwise, you will have to keep replacing the battery, and that does not only increases the cost, it increases overhead. So low powered wireless LAN is one of the key things when we are working on IoT project. So our wireless communication broadly we can classify in two parts. One is the short distance, second is the long distance, right? So let's say you have a truck, right, which is moving, and this truck has multiple IoT devices. It's a truck, and this truck has some very high value good. Let's say there are jewelries and there are multiple lockers, and all these lockers have jewelry. So you have a camera over here which will be monitoring. Then you have a camera here in the driver cabin which will be monitoring driver. You may have some door sensors over here, right? And in case there is a perishable good, you may have some temperature sensors. Then you may have a GPS over here to get the geolocation, right? And you have a Wi-Fi router here or a gateway over here, and all these devices communicate to the gateway, right? And then this gateway communicates to the cloud. Here, this communication, correct? This communication you need long distance, and this communication are short distance. Short distance communication can be through Bluetooth, Z-Wave, Zigbee, RFID or NFC. All these technologies can be used for short distance communication. So the first technology which is used in short distance communication is RFID or NFC. NFC stands for near field communication. Many of the mobile phones have NFC. Using NFC enabled mobile phone, you could simply do a wireless payments. Simply tap the mobile phone with the NFC enabled device, and both the device will communicate. NFC is a technology used for wireless communication in very short distance. The name itself says near field communication. This kind of systems are used to communicate between few centimeters to 10 meter. RFID, you might have already seen in shopping mall. When you go to shopping mall, the products have certain kind of tag, and when this tag come in the influence of electromagnetic wave, they will generate some kind of unique code. So RFID is a very popular, very old, it is still being widely used thing to, and primarily used for asset tracking, where you can attach the RFID with the product, and using which you can get a unique identifier of the product. Then BLE stands for Bluetooth Low Energy. So one is Bluetooth, which we all may be knowing. Our mobile phone has Bluetooth. It's very common. BLE is a specifically thing which is for IoT. It's called Bluetooth Low Energy. It's a version of Bluetooth only, but it consumes very less energy. And similarly, Zigbee is another short distance communication protocol. This kind of communication protocols are typically used for a range of 0 to 100 meter. Typically in the wearable gadgets and some smart home appliances, in healthcare solutions, these kind of systems are used. Then we have Z-Wave, which is very similar to Zigbee, and it is used for smart home devices, automation systems, healthcare systems, some gadgets. And then we have long distance communication protocols. So long distance communication protocol typically will be for the few kilometers. They are termed as either MAN, metropolitan area network, or wide area network. Wide area network is for larger geographies within multiple cities. If the communication has to be there, it will happen through wide area network, and within city or sub city, it is metropolitan area network. So one of the very popular thing is LoRaWAN. LoRaWAN stands for long range or low radius wireless communication, up to 2 to 15 kilometers in urban areas and up to 50 kilometers in rural areas. This is a very popular implementation used in implementation of smart city and industrial IoT. Then we have NB-IoT. NB-IoT is narrowband IoT. Narrowband IoT again has a range of several kilometers, and it is another technology very similar to LoRaWAN, which is used for smart cities, and it is used in smart metering, asset tracking. And then we have something called Sigfox, which is again 10 to 20 kilometers in rural area and 3 to 10 kilometers in urban area. It is used for logistics, remote monitoring. Typically, these kind of technologies are implemented for specific purpose, typically in a very big projects where you want to have a dedicated communication system and you do not want to have dependency on general public communication systems like satellite communication or cellular communication. So till now we have looked into little bit of networking, we have looked into basic architecture, and we have looked into multi-tier architecture also. Let's now talk about different layers of processing which happens in the IoT based system. So we have already seen cloud, there could be edge, there could be fog, there could be mist computing. So let's look into all these different layers. Let's first understand what is edge computing, and then we will go to the next level.